Chapter 15, Quantum Translation, Section 15.5, the particle in the three-dimensional box. For the particle in the three-dimensional box, assuming the dimensions are a, b, and c, we have the wave function of the 3D particle. It's the product of a function of x, a function of y, and a function of z. The x function is the square root of 2 over a sine n pi x over a. The function of y is the square root of 2 over b sine n pi y over b. The function of z is the square root of 2 over c sine n pi z over c. Because the three quantum numbers in the three directions can be different, I'm using subscripts n sub x, n sub y, and n sub z as the quantum numbers in these three directions. The energy of this three-dimensional particle is the sum of its energies in the x, y, and z direction. They take the same form. It's n squared h squared over 8ma squared in the x direction, n squared h squared over 8mb squared in the y direction, n squared h squared over 8mc squared in the z direction. I'm just assuming the box side length is a in the x direction, b in the y direction, and c in the z direction. Again, nx, ny, and nz are the quantum numbers in the x, y, and z directions. They can be different. Therefore, we add a subscript here, here, and here. n sub x, n sub y, and n sub z can be 1, 2, 3, 4, etc., and they can be and are often different. The wave function of the three-dimensional particle is summarized here. It's the function of x times the function of y times the function of z. So you can see this is mostly the one-dimensional particle in the box problem, and we have the square root of 2 over a sine n pi x over a. The other two wave functions of y and z are similar to that in the x direction. We just need to change the side length from a to b or c, the quantum number to n sub y or n sub z. And that's it. Over here we do have a typo. This should be z. For the particle in a cubic box, a equals b equals c. Now the three-dimensional energy is nx squared plus ny squared plus nz squared, and then multiplied by h squared over 8ma squared. A is the side length of the cube. Now, I'm listing the values of the three quantum numbers of the first 9 energy levels from the lowest to the highest. Over here, the three quantum numbers are all equal to 1. This is the lowest possible translational energy for a three-dimensional particle in a cube. So this is correspond to 1 squared plus 1 squared plus 1 squared. That's 3 multiplied by h squared over 8ma squared. Now what about the second energy level? It can be 211 or 121 or 112. Either way, we have 6 times h squared over 8ma squared. The third energy level, 1 squared plus 2 squared plus 2 squared. We get 9. 9h squared over 8ma squared. And also, we have a degeneracy of 3 here. Because when we have 1 to 2, this kind of combination, well, this one can be nx or ny or nz. The next level is 311 or 131 or 113 with a degeneracy of 3, because we have 3 sets of quantum numbers that correspond to the same energy. 3 squared plus 1 squared plus 1 squared, that's 11. Here we have a degeneracy of 1, 2 squared plus 2 squared plus 2 squared, that's 12. Now we have a degeneracy of 6. The three quantum numbers can be 1, 2, 3, but there are 6 different permutations. We can have 1, 2, 3 or 1, 3, 2. We can have 2, 1, 3 or 2, 3, 1. We can have 3, 1, 2 or 3, 2, 1. But either way, 3 squared plus 2 squared plus 1 squared, that's 14. So we can keep going and we can get more and more energy levels. Their energies in terms of h squared over 2a, 2ma squared are 3, 6, this is 3, 6, 9, 11, 12, 14, 17, 18, 19, etc. The degeneracy of all these 9 energy levels are 1, 3, 3, 3, 1, 6, 3, 3, 3, respectively.